So at this part of the examination, we are going to apply quite an innovative technique, which is called thermography. Thermography, or medical infrared imaging, is an emerging technology which has quite a lot of potential applications in the assessment of the diabetic foot. This type of technology measures heat which is emitted by any object, or in this case of the foot, which is above absolute zero. We know that any object above absolute zero emits heat, and this is the infrared part of the wavelength is measured using this special apparatus, which is known as a thermal camera. During clinical examination, we normally assess the patient's foot for whether it is cold or hot, because we know that heat gives us very good and important clinical data. And in this case, this technology is so sensitive that even the minutest change in temperature is detected by this camera. We have done a lot of research in this area, and we have established that in the normal foot, in the healthy foot, there is absolute symmetry between one foot and the other, which is quite an important derivation. So a symmetry of more than 2.2 degrees Celsius shows that there is a significant pathological process going on, and that needs to be investigated. Some other research that we have done has shown us that in the diabetic foot, which is neuropathic, or also which is neuroischemic, or which has peripheral arterial disease, it is quite surprising that the temperature of the affected area is quite significantly higher. And this can be seen even in this diagram, just looking at it. In the area of the ulcer, which is already showing how hotter it is by looking at the scale on the right side of the screen here, that the white area of the ulcer is quite hotter, which shows that area there is either maybe infection or metabolic activities going on in that area. So the thermal images we took of this patient can later be analyzed using proprietary software or other software which analyzes images, because each JPEG image has a series of information in it that will be important or provide us with important information. As we can see in the cursor position, each image, each pixel gives us there is the position, the X and Y position of each pixel, plus the temperature. In this case, it is 22.9 degrees Celsius. As can be seen, the thermal image can be analyzed using this software. There is even open source software that can be used. And it is quite similar to the way that we analyze this to analyzing foot pressure data. As we know, foot pressure data can be visualized using color and different shades of color, and to represent different pressures. In this case, the different colors, as we can see here by the legend, also represent different temperatures. These ranges can also be changed, like when we change these in foot pressure mapping technology. Also, there are various palettes that can be used, ways that can be used to visualize this data, to make a sort of qualitative way of seeing the image, to make it easier for us to see this. For example, this is called a medical palette. We will using another palette. In this case, it is called IMBO. So once we have the image, and in this case, I may repeat that the difference is so obvious from one area, from one foot to the same area of the other foot, but we can, for the sake of showing this technology, we can add an area of interest. In this case, we are going to add a polygon which is going to cover the area of the first MPJ, metatarsophalageal joint, where we know that there is the ulcer. In this case, we can see here that in this polygon the mean temperature is 32.1 Celsius, maximum temperature is 33, and minimum is 26.3. Doing another similar area on the first MPJ of the other foot in order to see the difference, and as you can see, I can alter the size and shape of the polygon in concern. I immediately see the huge difference in temperature. As I said, on one foot where there is the ulcer, there is a temperature of 32 degrees Celsius, while on the other foot it's 24 degrees Celsius. There is a temperature difference of 8 degrees Celsius. And going back to research that had been done by Armstrong et al., they told us that a temperature difference of about 2.2 degrees Celsius is indicative of a pathological process. In this case, obviously, an 8-degree difference leaves us with no doubt as to the difference and to the pathological activity going on in that area.
Okay, as part of the biomechanical assessment, we need obviously to assess the major joints of the foot. Okay, so if we start off with the right foot, which had a previous ulcer under the hallux, okay, we can go through the major joints, firstly by testing the dorsiflexion at the ankle joint, okay, where we slightly supinate the foot and we dorsiflex, okay, the foot at the ankle joint. Okay, we can see that there is movement, however, slightly restricted. Okay, if we move on to the subtalar joint, okay, and we invert and evert the hind foot, okay, we can see that there is movement, but again, there is some restriction there. Okay, so we must take note of these movements for later assessment. Looking at the mid-tarsal joint, okay, both longitudinal and oblique axis, you can say now that there is movement, even a bit, we can say this hypermobile at the mid-tarsal joint. Okay, so it's worth noting because there might be some clinical implications to that we might discuss at a later stage. Also, there is the first ray that we need to check. Okay, so motion in the first ray there, okay, and also in the fifth. Okay, you can say that there is good motion in both joints. Okay, we can also look at the movement in the hallux, okay, in the first metatarsophalangeal joint, okay, where we dorsiflex the hallux at its full range of motion. Okay, there is movement there, however, it's slightly restricted as well. Okay, applying the Jaques test, we can say that there is slight functional hallux limitus also. So that gives us a clear picture on the mechanics of the right foot. So proceeding to the left foot, where the presenting ulcer is, as we said, under the first metatarsophalangeal joint. It's worth also remembering that, as we said in our previous slide, that the lady did sustain a fracture after trauma and she was operated upon, so that we're envisaging that might restrict some of the motion in major joints. So as we did with the other foot, we start off by assessing the ankle dorsiflexion, okay, and again we can see that there is quite restriction in movement at the ankle joints. Okay, following that, we need to look at the subtalar joint, where we're trying here to invert and evert the hind foot with limited, almost non-motion. No motion is happening at that joint. As we said, the mid-tarsal joint, it's an important joint to be tested, both in the oblique axis and in the longitudinal axis, and similar to the other foot, there is a hypermobile movement within that joint. Okay, and again, it needs to be investigated. Following that, we need to look at the fifth ray. Okay, movement within that joint, which is we have good movement. However, the first metatarsophalangeal joint is slightly plantar flexed with good movement as well. Okay. Following that, we need to test for a movement within the first metatarsophalangeal joint by dorsiflexing the hallux. Okay, and we can say that there is hallux limitus, definitely. So assessing plantar pressures would be an important factor for treatment for this ulcer. So as part of the assessment, we also need to look and examine and assess both her insoles and the presenting footwear. So she has been prescribed and dispensed with insoles during treatment for the first ulcer, which was presented under the right foot. These needs to be reviewed and changed. Also, we can have a look at the presenting footwear. Here we can see that she has been prescribed stock therapeutic footwear. So obviously they come with special features such as extra depth. Okay, most of the time they're seamless, quite wide in front. Okay, and extra cushioning at the heel area. So all these are parameters that we need to assess, examine, and possibly change.